Okay, so we've been doing the 2 and 3 variable systems. I want to show you a tool today that's going to seem at first like it's unrelated, but we're going to tie it back in before we're done. We're going to talk about matrices. Some of you have been eagerly anticipating this. A matrix is nothing more than an organized set of numbers. There are a ton of uses for a matrix. In computer programming, they're called arrays, where they're just organized set of variables and values that are used by the computer system. They can be used one after another. In engineering, there's force matrices and shear matrices and stuff like that for describing forces on objects. You get into three-dimensional analysis and use matrices for stuff. We're not going to get into it because it's kind of complex. But there's a lot of things where the matrices are used. What we're going to focus on, first we got to understand a little bit about the matrices, the matrix. But from there, then we're going to look at some of the calculations behind it, and we're going to tie it back into our systems of equations. So a matrix might look something like this. Those square brackets around it signify that it is a matrix. This matrix is what we would call a 2 by 3 matrix. The first number is the number of rows. There are 2 rows. Second number is the number of columns. There are 3 columns. So this is a 2 by 3 matrix. There are all sorts of operations we can do with matrix. We can add matrices if they're the same size. We can subtract matrices if they're the same size. We can multiply matrices even if they're not the same size. There's a lot of things we do. What we're going to be concerned with is something called a determinant. Determinant can only be done with something called a square matrix. A square matrix is where it has the same number of rows as it does columns. And we're going to start out with a 2 by 2 matrix. There's a 2 by 2 matrix. A determinant involves down products, technically down diagonal products, minus up diagonal products. So looking at this, we've got 3 times 7 is 21. That's my down diagonal product. Up, I got 2 times 5 is 10. 21 minus 10, this is a determinant of 11. So here, my down diagonal product is what? 10. 5 times 2 is 10. My up diagonal product? Negative 24. 8 times negative 3 is a negative 24. So it is the down minus the up. So it's 10 minus a negative 24 is 34. Is that determinant? Now technically, I told you to find the determinant of this matrix. But I don't have to tell you to find the determinant. I can actually just use a symbol. If instead of having the square brackets, I just have lines, that is telling you find the determinant. Find the determinant in your notes of that matrix.
Can you spell that number?
What'd you get?
54.
Perfect. We got down, we've got 40. Up, we've got a negative 14. 40 minus a negative 14 is 54. What's that?
I was giving him throwing him the answer against whatever. I just saw fucking pain.
What's he over there flashing gang signs at me?
Yeah,
Or what?
Matrix game side.
That's our new math gang, the Matrices.
Okay.
I can see you guys hanging out at parks now. Hey kids, you want to join the Matrix? Turn it into a pyramid scheme of some sort. $5 entry fee, and just kind of pass it up the line. Okay, so why do we care about matrices? Some of you are probably sitting there thinking we don't care.
Couple of questions.
Yeah.
What's the simplest matrix? Is it a 1 by 2?
2 by 2.
2 by 2 is the simplest.
Well, a simplest matrix is just a number, 1 by 1.
Okay.
But you can't calculate the determinant of that. Determinant of any 1 by 1 matrix would be a 0.
So the simplest we can find is a 2 by 2.
2 by 2.
And what are the individual numbers called?
Entries.
Entries?
Yeah. Or elements, if you want to, depending on what calculation you're doing, they're sometimes referred to as elements, yeah.
So basically, I was going to ask, how does this apply to our everyday life?
Hopefully it gives us the easiest way to figure out these variables.
Yeah.
We will get to that. I mean, it applies to your everyday life. This is math. It doesn't apply to everyday. No, I'm just kidding. There are a lot of applications, most of which are going to be slightly beyond what you guys are training for. But like for the systems of equations, there are applications. Now, most systems of equations, I don't bother going to matrices unless I get a really large system, like a 3-variable system. I'll use a matrix just because this little tool right here will do them for me. As you saw there, that it did that opener problem for us. A 3 by 3 matrix is a little more work. First of all, if I just do a down diagonal, 3 times 5 times 4 is 60. And then do an up diagonal, 7 times 5 times 0 is 0. I've missed almost half the matrix, haven't I? So what we have to do is we have to do several down diagonals. Technically what happens is this down diagonal goes 2 times 3, and then it wraps around to hit 7. Make sense? Not at all. You ever play like Asteroids, the video game, like that, where you go off the edge of the computer screen, you come back on the computer screen on the other side? Yeah. Yeah, it comes this way and back over to here. But it's kind of like Pac-Man. It comes off one side and goes to the other. Simpler way of dealing with that, though, is just this. I'm going to take that first column and I'm going to rewrite it. That second column, I'm going to rewrite it. So I don't have to wrap around. I can just go right down the column. 2 times 3 times 7 is 42. 0 times 0 times 1 is 0. I add those all up. I have 102 as my down diagonal total. Now going up here, I had a 0. 1 times 3 times 3 is 9. 4 times 0 times 2 is 0. My up diagonal total is 9. So my determinant here is 102 minus 9, otherwise known as 93. What do you think? Not horrible? I'll give you time to take a picture. Do you want me to stand up by it and smile? Kind of like the two guys that got the selfie with the bald eagle. What's that? We'll slow down if you need to. Just say so if you have to, if I need to. That is true. Good point. I want you to attempt this one in your notes. See if you can make that one. I'm going to rewrite the first two columns. Be very careful of this because you'd be amazed at the number of mistakes I see just copying down those columns wrong. With just numbers listed in columns like this, it is really easy to like jump a row or a column and get the wrong number. So now going down, 513 is 15. 3, 3, negative 2, negative 18. 0, 2, 5, 0. Add that up, I got a negative 3 down total. How many of you had negative 3 for the down total?
I missed the negative.
Missed the negative, okay. Going up, negative 2, 1, 0, 0. 5, 3, 5, 75, 3, 2, 3, 18. Up total of 93. How many had an up total of 93? Forgot to do the ups? So now we've got negative 3 minus 93 equals a negative 96. How many had negative 96? 1?
I would have, and I that negative.
Okay. Maybe we should try another one. Just maybe. Try that one quick. So I'm going to rewrite my first two columns. And then we're going to do the down product. 7, 4, 7 makes 96. 3, negative 5, 2, negative 30. 8, 0, negative 3 is 0. So 166 is the down total. How many of you had 166? Going up. 248. 624. Negative 3, 5. Or negative 3, negative 5, 7. 105. 703. 0. So a 169 up total. 166 minus 169 equals a negative 3. We got negative 3. Okay. I don't know. Sometimes we do a determinant by something called an expansion. And minors. Let me show you what I mean. I'm going to give you this matrix right here again. 7, 3, 8, 0, 4, negative 5. And 2, negative 3, 7. There are two things we need. Each term in a matrix has two things that we can be associated with it. One is called a cofactor. Now the cofactor is either the value of the entry or the element or the value times negative 1. So like here, the 4, its cofactor is either going to be 4 or negative 4. Well, how do we know which one it is? We look at its location. So for the 4, what row is it in? That's in the second row. It's in row 2. What column is it in? You just said it 2. What's 2 plus 2? 4. Since that is an even location. It's positive 1 times the element. So positive 1 times 4, it's a cofactor of 4, right? So it's just the number. If it was an odd location, it would be -1 times that entry.
Okay, so do you need the one there? Because that,
Well, it's just for consistency, because if it's an odd location, it's a -1 instead of a +1.
right.
You don't really need it, no.
Plus or minus.
Yeah. But like if it's a negative, if it's in an odd location, it becomes positive.
Right.
So you gotta be careful, yeah. It's either that number or that number times -1.
But it's still going to remain that number.
Yeah. The second thing each entry has is something called a minor. The minor is found by taking out the row and the column. So 4 is in row 2, column 2. What's left? Seven, 8, 2, 7 are what's left if I cross out that row and column. That makes sense? So what happens is this 3x3 matrix, if I pick an entry, I get its cofactor and a 2x2 matrix. The determinant of a matrix can be found by expanding any single row or any single column. And an expansion is each entry, for each entry is its cofactor, times the determinant of its minor, plus the next entry's cofactor, times the determinant of its minor, and so on, until you've completed the whole row or whole column. That works for 2x2, 3x3, 5x5, 8x8, 27x27. Now, why am I showing you this? For a 3x3, isn't it just easier to rewrite the first two columns and do the diagonals? Yeah, it is. That's how I do a 3x3. But if you get bigger than a 3x3, the diagonals don't work anymore. You have to expand it. I can see the looks on your faces. You guys are looking forward to that. So let's expand this. Now, I am going to expand this either by row 2 or column 1. Why would I choose those two things? What's in both of those? A 0. Why would I choose a row or a column with 0 in it? Yeah, the cofactor of 0, whether positive or negative, is going to be 0. 0 times the determinant of its minor is going to be 0. It saves me some work. If you haven't figured it out by now, I am a little bit lazy. I will save work wherever I can. I'm going to use column 1 because those are all positives. Now, they're not necessarily going to stay positive, but let's do it. So over here, we're going to make a little table. The entry, its cofactor, and the determinant of its minor. And then we're going to get a value here. So the first entry in that column is 7. It's cofactor. Well, it is in row what? 1, column 1, adds up to 2. That's even, so the cofactor is just a 7. The minor. If I take out the column and the row, I am left with 4, -5, -3, 7. Does everybody see where that minor comes from? No? Well, we're expanding about the 7, right? We cross out its column, or its row, cross out its column. That's what's left. Still confused. Yeah. But we took out this row. We're expanding about the 7, so we take out the row that contains the 7. So that's gone. The 7, 3, 8 are now gone. We just erased them. So we take out the column that contains the 7. So the 7, 0, 2 are gone. All that's left is 4, -5, -3, 7. The minor is always going to be one row and one column smaller than the whole matrix. because you're taking out a row and a column. Now I have to do a determinant for that minor. So that's going to be 28. This is going to be 15. 28 minus 15 is 13, right? Down minus up. Everybody see where the 15 comes from? Or the 13 comes from? So then the value, 7 times 13 is 91. That is the value of the expansion for the 7. Now what's the next entry in the column? 0. I'm going to skip all that crap and go to its value 0. Why? Because its cofactor is 0. 0 times whatever that minor is still 0. So nothing else matters once the entry is 0. Next entry in that column is 2. What row is it in? 3. Column 1. That adds up to 4, which is even, so it's going to be positive. So it's going to be 2 is its cofactor. Can you tell me what its minor is? Obviously, the column 702 is gone. What row goes away? The bottom one. So what's left?
3, 4, -5.
Yeah, 3, 8, 4, -5. So then we got 3 times -5 is -15. 4 times 8 is 32. So -15 minus 32 is a -47. 2 times a -47 is a -94. Now we add up those values, we get -3 is our determinant. Guess what? That's what we got before. Now, this may be easier, it may be more difficult, depending on who you are. But like I said, if you get into a 4x4, you have to use those minors. You have to expand. Want me to go back and get a picture? There you go.
What did you multiply -47 by?
2 times -47. It's the cofactor times the determinant of the minor. Let's do another example, and then we'll let you guys try one.
What does the values tell us, though?
The values, we add up these. What does this determinant tell us?
Yeah.
It's going to take us a while to get there. There's a lot of things it could tell us. We're only going to look at 1 or 2 of them.
And where do we get these inputs from?
These values here, we got to get there yet too. There's a lot of different places those can come from depending on what you're using the matrix for. Like if you're doing a shear matrix, you would, like a shear matrix on a building, you would have, the wind, the miles per hour of the wind, and the density of the air, and all sorts of things with different entries. And you could do the determinant of that matrix will give you determinant of that matrix times the determinant of the matrix for the structure of the building will give you the shift of the building. All sorts of different things are used for. We're not going to get into that detailed part of it. So here, I can either expand. Well, what would I expand around? What if I was going to expand around a column? Which column would I probably want to use? Column 1, the one with the 0 in it. Which row would I probably want to use? Row 3, because there's a 0 in it. So I can either expand around column 1 or row 3 if I want to take advantage of that 0. Which one would I rather use most likely? Usually I'd stay with the one with positives, but really it's about the same amount of work if you're okay with working with negatives. Because we did a column last time, I'm going to expand around a row this time. Nope, one or the other. Up here, remember, we only did this column. Now, for each entry, we excluded the column and the row when we did the minor. But you're only expanding around the 702 that we expanded around.
And does it matter?
Doesn't matter. You can pick any row, any column.
The operation row.
Yeah. But I wanted to do a row just so you could see it done. entry, cofactor, minor, expanded value. So the first entry in that row is 0. And the rest of the stuff I don't care about because its value is going to be 0. Next entry in that row is 4 for the cofactor. That is in row 3, column 2, which adds up to 5, which means it's the opposite, -4. 4 times -1 is -4 is my cofactor. My minor. Without me doing any drawing in there, can anybody tell me what the minor is?
7, -4, 5, 1.
Perfect. 7, -4, 5, 1. Because I'm going to exclude this first row here, or first column, because the 0 is in it, and I exclude the row that we're expanding around.
You have to exclude the first column.
Well, if we're expanding around, oh, wait a second. We're not expanding around 0, are we? We're expanding around 4. To exclude. If it was a 0, that would have been the minor. It's not. Expanding around 4. It's 2 -4. 3, 1. Because 4 is in this column, so that's the column I get rid of. Don't worry, I got caught on that one too. So now, 2 times 1 is 2, 3 times -4 is -12. 2 minus -12 is a -14. So -4 times -14 is 56 is the value for the 4, the expansion value for 4. Positive 14, you're right. 2 minus -12 is positive 14. So that should be a -56. Thank you. I'm having an off day today for some reason. Does that make more sense? It's Friday. I wish I could say I was on the weekend already, but I'm not. Any questions? Other than why do I keep screwing up? The next entry then is going to be what? -2. Okay. What row is -2 in? 3. Column 3, which adds up to 6. So it's just a -2. It's just that number. If it was in an odd position, it'd be -1 times that would become a +2. It's the opposite of it. Negative. It's not automatically positive because it's in an even spot. It's just that value because it's in an even spot. If it's in an odd spot, it's that value times -1. So it's minor. You got it. 2, 7, 3, 5. 2, 5 is 10. 3, 7 is 21. 10 minus 21 is -11. -2 times -11 is a 22. -56 plus 22 is -54. What do you think? Somebody scroll up. I think it's time for you guys to try one. So go ahead, expand this, pick a row or a column. And expand it, and we'll talk about it in a minute. Okay, so what row or column did you expand about? You did column 2. Did anybody do row 2? Cool, perfect. Because I want to do both just to prove to you that it works. So I expand around column 2 first, 301. Cofactor of 3 is going to be -3. Row 1, column 2, that adds up to 3, so it's going to be the opposite. It's minor. we go. So that's going to give us what, negative 20 and 6, so negative 26. So this is a positive 78 is our value. The 0 is just 0, no matter what. The 1 is a cofactor of negative 1. Row 3, column 2 adds up to 5. It's minor. 4, negative 2, 5, 3. This is 12, negative 10. That makes for 22. 12 minus negative 10 is 22. Then negative 22. You get a determinant of 56. Did you get 56? Did everybody else get 56? Well, let's take a peek. What would happen if we expanded around row 2? Well, 5 has a cofactor of negative 5, row 2, column 1, right? A minor of 3, negative 2, 1, negative 4. So this is negative 12, negative 2. Negative 12 minus negative 2 is a negative 10. That gives us a 50. 0 is a 0. Expanding around the 3 has a cofactor of negative 3 because it's in row 2, column 3, adds up to 5. Its minor for the 3 is 4, 3, 2, 1. This is 4. This is 6. 4 minus 6 is negative 2. Negative 3 times negative 2 is a positive 6. 50 plus 0 plus 6 is 56. You catch your mistake, Dale?
Yep.
Okay. What do you think? So I could pick any row or any column in this matrix, and I should get the same value of the determinant. Or I could do the diagonals, and I should get the same value of the determinant. What do you think? Yeah, that'll look like, make it end.
Well, we're working on 3 by 3. I think that the
Diagonal.
crossing way is easier.
It is. Here's the problem, though. When you get up to a 4 by 4, you can't do that anymore. Diagonals won't work. I cannot rewrite the first 3 columns in diagonals. It doesn't work. So I have to pick a row or column. I'd probably pick like this row. Then I have to expand. Now my minors are 3 by 3. So I have to do the determinants of the 3 by 3 matrices, which I could do diagonal if I wanted to. Now here's what really sucks. At some point, I will give you an extra credit question. Five by 5. I'm just going to pick a row. Let's pick that row. There's 2 zeros in it, so it makes it easier, right? The extra credit question might not have any zeros in it. If I give you an extra credit question, it might not have any zeros in it.
Yeah, okay.
So the expansion for the 2, its cofactor, it's in row 3, column 1, so that's a 4. Its cofactor is just 2. It's minor. Well, 3, 8, 4, negative 2. 1, 3, 5, 6. 1, negative 6, 3, negative 2. 2, 8, 0, 1, right? Well, I've got to take the cofactor times the determinant of that matrix, that minor. Guess what I got to do to find the determinant of that minor? I got to pick a row or a column. I got to expand it. So, if there's no zeros here, I'm expanding around 5 different terms here, right? But each of those terms has a minor that's 4x4, and to get each minor, I've got to expand around 4 different turns. So 5 expansions, each with 4 of its own expansions, is 20 expansions. I know I'm enjoying that way too much. That's why, yes, if you have the graphing calculator, you throw it in there. Blah, 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 it's done.
So how do you put that into a calculator?
You gotta have a graphing calculator with a matrix menu in it. The good news is, for tomorrow, I'm just gonna have you do 2x2 matrices. In your big book, page 417, for Tuesday, I should say, exercise 17-5, 1 through 10. Those are just 2x2s. There are some decimals and fractions in there for you to play with, though.
You kidding?
Does this grin look like I'm kidding? Yes, you are.
I was checking out my grade, it says I missed the 4-point question quiz.
Oh, that was like circle the horse.
Oh.
There was like a few people gone. There's only like 3 people in the room. There's only like 2 or 3 people in the room, so we did. What's that?
Can you remember which one we finally picked to do?
Yeah, something like that.
So what do you give them quizzes when people
Just the
are
odds.
gone usually?
When like I look around the room, there's only a couple of people in the room. I'll give those quizzes. But it's not. I make sure you don't like totally. It's not gonna like totally destroy your grade.
It was one of those really tough ones, like which one's the cat?
I know. I heard that line.
I used to have my pop quiz. You know what pop is referred to as the uncola. What pop is? It's got 29 different flavors.
I was trying to remember what ones you could pull.
7 Up.